Okay, we're going to go ahead and get started today. And so what you're seeing projected is roughly what we expect to see on the Math 112A midterm exam. And so we provide this guide as an example of questions that you can draw from if you don't have questions of your own that you would like to drop in the chat or speak out loud for us to answer. So first, I'd like to talk to you about, learning outcomes. So what I've done is I have arranged all of this material by student learning outcomes. And the great thing about student learning outcomes is they allow you to look at a question and break it down in a strategic fashion so that you can answer the question efficiently. So most of these textbooks are going to have student learning outcomes listed somewhere. And so this document that I will start dropping into the chat as soon as we have everybody in it, this document contains all these learning outcomes from your textbook with example problems. These learning outcomes are based on Bloom's taxonomy, where we can start at the bottom of the pyramid, remembering information, and work our way up to the top of the pyramid, creating information. I want to grab that, drop it in the chat. There you go. Oh, that wasn't it. Let's try this one. Okay, so we're trying to get this file dropped in the chat. Oh, that one. Okay, so the Math 112 midterm review has been dropped in the chat. That's the document that we're projecting right now. So if you have questions about what we're talking about, you can go back to this. Now, this is a huge document. We're not going to go through the entire document, but we will go through each section of the document and let you pick a question or two, and we can work those out for you and help you get them set up. So with these learning outcomes, we want you to see if you can recognize all the terms in the question. That's the first thing. If you don't recognize the terms, you need to look those up, especially in math. Sometimes they say things in a particular fashion and a word will carry a big meaning. But if you're not aware of that, then you won't know where to start. Also, do I understand what the question is asking me to do? Can I find examples of questions that match this learning outcome? That's what I've done for you with this packet. And then the purpose of this session is to see, can you answer the question and you know how to check your work? So if you answer no to any of those questions, that tells you where to go back and focus your work. All right, next page. Okay, so we've got chapter 1 and chapter 2 to go through. And if you have questions you'd like to see answered, feel free to drop those in the chat. I'm going to take a couple of seconds and get this switched over so that Madison can get us started. Stephen will be joining us in just a little bit. And I will keep dropping that review packet into the chat for those people that are just joining us. All right, so without further ado.
All right, so hi everybody, my name is Maddie. So we can just jump right in. Chapter 1 is all about the functions, graphs, and models, linear functions. So are we going over the toolboxes? Okay. So the chapter 1 algebra toolbox, we have, for the first thing, we write sets of numbers and identify elements, subsets, intersections, and unions of sets. So thank you. Does anybody want to go over some examples from this section? So you can feel free to either use the chat or you can unmute yourself if you want any specific questions to go over. If not, then we can just keep going through and we can move on. So we have identify sets of real numbers as being integers, rational numbers, and or irrational numbers. Does anybody want to go over any of these examples? Number 10, please. Okay. So number 10, we have radical 3 pi, the cube root of 2/4, and the square root of 5. And so what we have to do, we have to identify the sets of real numbers in exercise 8 through 10 as containing one or more of the following: integers, rational numbers, and or irrational numbers. So looking at the first number, we have the square root of 3, and then we have pi, we have the cube root of 2/4, and then we have the square root of 5. So right off the bat, we know that pi is an irrational number because it cannot be expressed as a fraction. And same with the rest of the numbers. So radical 3 and radical 5, we also cannot express as a simple fraction. And then the cube root of 2 in this number, in this fraction, is the same way. Since we can't express the cube root of 2 as a fraction itself, we also know that that is an irrational number. So this whole set, we have 4 irrational numbers. Are there any more that you guys want to go over from this section? All right. 18, please. Okay, so simplify arithmetic expressions. Number 18. We have all right, so we have -8 times -3, first of all. That's where we'll start. And so simplifying this, we'll have 24 plus, and then we have 5 times -2. So we have -10. And then divided by, we have a 3 times the -4. So that 3 times the -4, we're going to get a -12. And then we have minus a -5. And so that minus a negative is going to turn that into just adding a positive. So we're actually going to have -12 plus 5. And then we're going to simplify this further. And we're going to have 24 plus a -10. Same thing as 24 minus 10. So we're going to have 14 and then divided by -12. We have a -12 plus 5, or we can also look at it as 5 minus 12. And for that, we are going to get a -7. And so turning this into fraction, we have 14 divided by -7. So we're going to get a -2. Are there any more problems from this section that you guys want to go over? $20, please. Okay, so number 20, we have 0 divided by -6. So for this, when we're dealing with zeros and division, you can divide 0 by any number and you're always going to get a 0. But you can't divide by 0. So for 20, you would get 0. For 21, also do this one, 5 divided by 0. You can't divide by 0. So that is actually just going to be undefined. So to just keep it, you just have to remember the difference between dividing by a 0 and dividing 0 by a number. Does that make sense? All right. So we can move on to the next section. Use properties of real numbers to rewrite expressions, complete statements, and solve equations. Are there any questions from this section that you guys want to go over? (26B). Okay, use an identity property to complete each statement. So let's find the identity. So we have an additive identity, and then we also have a multiplicative identity. So the multiplicative identity states that 1 for any real number a times 1 equals a. So for 26, we're going to have blank times 3 equals 3. And we know that any number a times 1 is going to equal a. So that'll just mean we can fill that blank in with 1 because any number times 1 is just going to be itself. 22 a and b and 24 a and b.
1.
Okay, so we're going to pick 1. And somebody also said 23. So see, 22, 23, and 24.
23A maybe,
Okay.
and 24A.
So we're going to do 23A and then 24A. So not B. So we have 8 plus -2 plus 3 equals 8 plus blank. And so for 23A, it says use an associative property to complete each statement. And if we look at the associative property, it says that the sum of 3 numbers is the same if the first pair or the last pair is added first. That is a plus b plus c equals a plus b. in parentheses plus C. So this is going to mean that 8 plus -2 plus 3 is going to be the same thing as 8 plus 3 plus -2. So when we rewrite this, we can actually rewrite this as 8 plus 3 plus -2. Because it's the associative property says that we can either add these first or we can add these first, and you're going to get the same answer. Now we can go over 24a and use the distributive property to rewrite each expression. So we have 6 times 12 plus 5. And the distributive property says that you can distribute this number into the parentheses and then add. So when we distribute this, we have 6 times 12. $72. So we're going to have 72 plus, and then 6 times 5 is going to be 30. So we can rewrite this as 72 plus 30 when we distribute that 6. All right. So we're going to move on to the next section. We have convert between inequalities, intervals, and graphs. Are there any of these problems that you guys would like to see? $35. Okay. So for 35, we have to graph the inequality or interval on a real number line. And so we're given 5 is greater than X, which is greater than or equal to 2. Okay. So we're gonna have 0, 1, 2, 3, 4, 5. So we have this 5, which is not an or equal to, and then we have this 2, which does include that equal sign. So when we graph it, we're going to use the bracket for the 2 because of this, and then we have the parentheses for that 5 because it doesn't include that equal sign. Does that make sense? Okay. So moving on, we have identify the coefficients of terms and constants in algebraic expressions. And then we also have evaluate algebraic expressions. Are there any questions from this section that you guys would like to go over? 37. Okay. So we have negative 3x squared minus 4x plus 8. So we want the coefficient of each term and the constant term. So the constant term is always going to be that plus whatever at the end. So the constant is just going to be whatever number is by itself without a variable. And the coefficients are going to be these numbers in front of the variables. So for the coefficients, we have a -3 and a -4, and the constant, we have that +8. All right, so now we have remove parentheses and simplify algebraic expressions. Any questions from this section that you'd like to go over? $45. Okay, so simplify the expression. $45 and $50. Okay, so we have a 3x plus 2y to the 4th minus 2x cubed y to the 4th minus 119 minus 5x.
Yes.
Oh. Okay. Minus 5x minus 3y squared plus 5. Sorry, guys, it's going to go over a little bit. 5y to the 4th plus 110. So when we are simplifying this, we're going to look at combining our like terms. So what I mean by that, we have this y to the 4th, and we also have another y to the 4th over here. And then we have this x here, and we also have another x over here. So combining these terms, we're gonna, this 3x minus a 5x, we're gonna have a -2x, and that gets rid of these. And then we also have a y to the 4th, or 2y to the 4th, and then a 5y to the 4th. So when we add these together, we're gonna get a plus 7y to the 4th, and that cancels these out. And then we also have two constants. So we have a minus 119 and a plus 110. And when we combine those, minus 9. Minus 119 plus 10. Yeah, so we're going to have a minus 9. That's going to cancel these out. And then what we have left over, we can't combine any further. So we'll still just have a minus 2x cubed y to the 4th and a minus 3y squared. And then we can go over number 50.
So you can see with the iPad.
And we have a 4.
Plus function, and that's how she's dropping down these little notepads.
Sorry, guys.
Yeah, sorry, we're distracting.
No, you're fine. So we have a 4 in the parentheses 2x minus y. And then we have a 4xy minus 5 parentheses y minus xy. And then we have a minus in parentheses 2x minus 4y. So first we're going to distribute these numbers into the parentheses. And we're going to get an 8x minus 4y. And then just continue on with the expression. We have a 4xy. And then we're going to distribute this 5. So we're going to get a minus 5y. And then plus, because these two negatives create a positive. So we're going to have a plus 5xy And then we're gonna distribute this negative into the parentheses. And so we're gonna get a minus 2x plus 4y. So when we simplify this further, we're gonna again look at combining like terms. And so we have this negative 4y and a plus 4y, and those are just gonna cancel each other out. And then we also have another y right here. We have a minus 5y. So we'll start there. So we're done with those. And then we have an 8x and a minus 2x. So combining those, we're gonna get a plus 6x. So now we're done with these. And then we have a 4xy plus a 5xy. And combining those, we're gonna get a plus 9xy. So this is the simplified expression.
All right. Pick up the pace just a little bit.
Okay. So this next section, we have plot points on a coordinate system and use subscripts to represent fixed points. Any problems that you guys would like to see? Doesn't matter which numbers go first in the answer. Like on number 50, problem 45. So no, not necessarily. Number 50. Yeah, so either one, no, it doesn't matter which numbers go first, like when you're writing out the answer. It's still going to be the same expressions as long as those numbers stay consistent with the variables that they're with. Okay. So we're going to move on to 1.1 functions and models. Would you like to switch?
Hello, everyone. You're doing well today. Okay, so where are we right now?
Just 1.1. We're just going through the
1.1.
sections.
Just gonna go through the sections. Okay,
Mhm.
so just start with number 2 here.
Just ask if they want to see any of the problems worked out.
All right. Anyone on this page have any questions or concerns with these problems?
All right, move on to the next. Oh, we got a 4.
4.
Yeah.
All right, number 4 states use table B to find y equals g of -4 and y equals g of 3. For the blank, right?
Yeah.
Put this over here and then.
Let's not play with the pen. Let's just try and get the paper.
Yeah, sorry.
You're fine. Can't help you out.
Yeah.
So if you want to move the post-it.
Or if there's space, don't even mess with a post-it. I would not do a post-it in this
Yeah.
case.
All right.
You can just write it on.
So we're asked to find g of -4 and g of 3. So let's start with g of -4. So on table B, you're given a list of x values and you're given a list of corresponding y equals g of x values, right? So if we're finding g of -4 in this table, it's essentially asking what is the value of g when x is equal to -4 is what that notation means. Therefore, if we go to table B and look to where it says x equals -4, its corresponding g value will be 5. Therefore, g of -4 will equal 5. Do you see that? Yeah. So can someone tell me what g of 3 would equal? Correct. Nice job. All right. Anyone else got a question? No other questions?
Okay, you want, yeah, we're.
All right. Any questions on this page?
She's asking me to go back a page, number 8, I think.
Oh, no, that was just the answer that I gave.
Oh,
That was an answer I asked for.
okay. 62.
62. So question regarding profit. The profit from the production and sale of iPod players is given by the function P of X is equal to 450X minus 0.1X squared minus 2000, where X is the number of units produced and sold. So are you asking about both A and B?
So we need to cover that for sure.
Okay. We'll make sure to say it down there.
That's 640. 650. Okay. Is it- yeah.
Just B? Okay. Let's try this again. So we are given this function of P of X. And we're asked to find what is the profit of the production and sale of 4,000 units. So remember that X is the number of units produced and sold. So what it's effectively asking us is that what is our profit when X is equal to 4,000? So the value we're looking for is P of 4,000. And if you remember to the previous problem we did, is that this notation means the value of P when X is equal to 4,000. So what we're going to do is that we're going to do exactly that. We're going to let X equal 4,000. And it's 2,000, right? Just want to get a calculator out and calculate that real quick. Yep. 84 in my front pocket.
Yeah, you got it set up. That's good enough.
I swear. So 450 times 4,000 minus 0.1 times 4,000 squared minus 2,000. So we'd expect our profit to be 198,000. Get that process. So we're gonna move on to oops.
Yep.
Okay, any other questions on this page? Before we move on,
Yeah, we need to move on. We're way late.
yeah,
Um,
questions on this page? No questions? I'll move on to the next one then. Any questions on this page?
On page 27.
Any questions on this page?
Encourage them to take these word problems to the tutoring center and move on to the next section.
Right. Yeah, so for the for these word problems, we're just gonna ask that you visit the tutoring center if you have questions, because we want to try and get through all of this.
Yep, keep going. There we go.
Yeah, graphs and functions. This is like considering these are like using graphing calculators, should we let them see the tutoring center about this as well? Or
we can take general questions.
sure. Any like general questions regarding like the use of the calculator?
Okay, go ahead.
Scatter plots.
Encourage them to use a t-table. Ask them if they have any questions over these.
Yeah, so a t-table would be a good idea when it comes to stuff like this, because really when you're trying to create scatter plots, you're using your list of coordinates to make a bunch of dots on the XY plane, right? And it would also be a pretty good idea to visit the tutoring center. Question for that.
25, please.
25.
Use a
Okay.
calculator. We can't do a calculator.
Yeah, we can't really do a calculator. It's a t or t is the other function. So it is asking that you, I believe it's asking that you use the table function on the calculator to solve for this.
Yeah, we don't have time for that.
So like for that, I recommend like you talk to the tutoring center about it.
Are they able to use the calculator on the exam?
Yeah, they should. I mean, I hope so.
Okay.
I mean, a lot of these questions are built around using the graphing calculator, so I'd imagine it'd be all right. Table and parts flow. Yeah, a lot of this is just using graphing utility methods.
Keep going.
It's so linear.
And then at the bottom of page 21, Madison has some information to cover.
27.
27. Okay, never mind. 27.
Page 27.
Okay, ask them if they have any questions over 19. Page 19.
Yeah, any questions over 19? No questions?
Okay, move on.
Any questions on page 20? Okay. Questions on page 21? Questions on page 22? Questions on page 23? Page 24.
So go ahead and slide past this one.
Yeah.
All right.
Equations of lines. So for the last
Somebody has question on one.
on one, is this for 1.4?
Yes.
Right. Okay. Someone said 18, so I'm not sure which one they're
If
referring
there are
to.
one, I'll figure out 18.
Yeah. Okay, so we're writing the equations of lines given conditions, and we're told that the slope is equal to 4 and that the y-intercept is equal to 1/2. So if we go to the definition over to the left in the blue box where it says slope-intercept form of the equation of a line, it says here the slope-intercept form of the equation of a line is slope m and y-intercept b. So it will be in the form y is equal to mx plus b. That is to say that y will equal your slope times x plus your y-intercept. So if we want to make the equation of a line whose slope is, I forgot what the slope was. The slope is 4, y-intercept is 1/2. M will equal 4 and b will equal 1/2. So we simply plug in these values. Y is equal to 4x plus 1/2. That will be our line. Right? Any other questions on this page? Okay. Questions for 27?
So for that one, I do have to go over something. On page 27.
On page 27.
Yeah.
Which parts do you want to just take over here?
Yep, that's fine. So while we're looking at page 27, we do want to go over some things about parallel and perpendicular lines. So we know that m is the slope in an equation, and parallel lines are going to have the same slope. So they're going to have those same m values. Perpendicular lines, you're actually going to have one slope is going to be, we'll do parallel and then perpendicular. Parallel is when the slopes are same. Perpendicular is where you're going to have one slope is m and one slope is going to be the negative reciprocal, which is just going to be it'll have the fraction will be flipped and it'll be negative. So we know that perpendicular lines, so it's going to be when there's like a 90-degree angle between the lines, and then parallel is when they go on forever without touching. So yeah, we just wanted to include that. Are there any questions about that? All right, so we're gonna move on.
Doing well.
So write equations of lines for given rates of change and find average rates of change. Do we have any questions about this section? All right. Find the y-intercept of a line given a point and the slope.
Maybe just ask by page.
All right. Do we have any questions about this page? We find the difference quotients and determine whether a linear function can be used to model data and if possible, write the function. 34.
Always. Call that one.
Oh, actually, we don't need one. So For 34, for the functions given in exercise 33 through 36, find f of x plus h minus f of x over h. So we're given that f of x equals 32x plus 12. So when we find this right here, we're going to have, we're going to input x plus h in for this x. So we're actually going to have 32x plus h plus 12, and then minus f of x. So we're just going to have 32x plus 12 all over h. So now we just want to simplify this. So we're going to distribute. We're going to have 32x plus 32h plus 12 minus 32x minus 12 all over h. So this is going to cancel out. We're going to have 32h over h. These will cancel. And so we're just going to have 32. All right. So what about this page? Do we have any questions about this page?
You guys feel free to trade back anytime. Move on.
Answer questions involving linear equations. Any questions about this page? All right. And that is the same section. So we're going to move on to chapter 2. We're probably not going to spend as much time on this algebra toolbox. If you guys have any questions, just look through this and let me know. If not, then we are going to move on to 2.1. All right. So now we're going to be looking at algebraic and graphical solution of linear equations. Do we have any questions about this first page? All right, so we're just gonna solve these equations. So we're given 5x minus x minus 2 plus 7 equals negative 2x minus 9 minus 8. It's 3x plus 6. Sorry, guys, I'm running out of room. So let's go through and start simplifying each side of the equation first. So we're gonna distribute this negative into that parentheses. So we're gonna have 5x minus x plus 2 plus 7 equals, and then same thing over here. We're gonna have a negative 2x plus 9 minus, and then we're gonna distribute this negative 8. So we're gonna have a, is that 24? So minus 24x. And then that's 42, 46 times. And then we have a minus 48. So now we're just going to combine our like terms. So we have a 5x minus x. It's going to give us a 4x. 2 plus 7 is 9. And then we have a negative 2x and a negative 24x. So we're going to have a negative 26x. Now we have plus 9 and then a minus 48. So 9 minus 48. We're going to have a negative 39. And now we want to solve for x. So we're going to add 26x to both sides. We're going to have a 30x plus 9 equals negative 39. And now we want to get the x by itself. So we're going to move that 9. We're going to subtract that 9 from both sides. That's going to cancel out. We're going to have 30x equals negative 48. And then we're just going to divide by that 30 to get that x by itself. So we're just going to be left with a negative 48 over 30. All right. So now we're going to move on to this page. Are there any questions about this page? Can you solve these graphically by finding the intersection? Yes, so you can do that. Go back up here really quick. So if you graph each side of that equation, that intersection will give you that x value.
They have to be in y-intercept, like slope-intercept form first.
Yeah, so you mean like simplify it first and then put it in?
Well, you need to find what y is equal to put it in slope-intercept form, and then you set the two equations to like equal to each other. So you're finding the value of y, and then you're setting the two equations equal to each other is what I'm trying to say.
Okay.
Just to like specify what exactly you're needing to do.
Okay. So yeah, let's move on to this next page. Were there any questions about this page? (22). Okay. Solution to the equation f of x equals 0. And then find the x-intercept of the graph and the 0 of f of x. So we have f of x equals x minus 5 over 4. So for part A, we want to find the solution to the equation where f of x equals 0. So if we set this equal to 0, x minus 5 over 4 equals 0. Multiply that 4 to both sides, and we're just going to be left with x minus 5 equals 0. And then when we add the 5 to both sides, we're going to have x equals 5. So for B, find the x-intercept of the graph. That's going to give us the same thing. So each of these, what these problems are trying to show you is that the x-intercept of the graph, the 0, and where f of x equals 0, those are all going to tell you the same thing. So are there any more questions about this page? All right. Any questions from these sections?
You guys ready to swap?
Yep.
Awesome.
My turn. Oops. All right. So questions on this page, I see 22. Oh, 44. It's 44 on page 40, right?
Yeah, 44.
Okay. So being asked to solve 4 times quantity a minus 2x is equal to 5x plus c over 3 for 3. So we need to get x by itself. So let me write this out. Now there's different techniques that you can use to get x by itself here. And considering we're dealing with variable a and c here, we're not going to get a constant value, but we're still going to solve for x anyway. So what I'm going to do first here is that I'm going to distribute the 4 to the u and minus 2x. So this should equal 4u minus 8x will equal 5x plus c over 3. Now what I'm going to do is that since I want x to be by itself here, I'm going to first subtract 4u on both sides. So I get negative 8x equal to 5x minus 4 times u plus c over 3. And what I'm going to do now is I'm going to start subtract by 5x on both sides. I'm running out of room here, but I'll manage, is equal to negative 13x is equal to negative 4u plus c over 3, right? Now, what I'm going to do now finally is that I'm going to divide by negative 13 on both sides. So I'm going to write down here x equals negative 4u plus c over 3 divided by negative 13. And if I'm probably going to be asked to simplify this. So when you divide by a negative number, you're changing the sign on the top as well. So I'm going to change the sign at the top, make this positive at the bottom here. And so it's going to look like c over 3. Hold up, sorry. 4u minus c over 3 is over positive 13. If I wanted to simplify that further, I suppose I could multiply the top and bottom by 3. But for the sake of time, I'll just leave it at that. Right. So go ahead and erase all this. What's the next one? Don't need to worry about that. Function. I'm not going to worry about that. Without graphing, determine which of the following data sets are exactly linear, approximately linear, or nonlinear. That's kind of hard to see.
Yeah. Just asking if they have questions on that page.
Questions on this page? Okay.
Move on. Yeah, this is data modeling, so I'm going to move on to the next one. Good, good. Same thing with that one.
Yep. Okay, system of linear equations. This is the good stuff.
Yeah, there's gonna be questions.
Yep, questions on this page.
Yes, number 2.
Number 2.
Pick A or B.
What was the question asking? Determine if the ordered pair is a solution of the equations given. Okay, so this is just a plug and chug. So we're given a system of equations, which is a list of equations with the same 2 variables, x and y. So the idea behind these equations is that there's only one pair of x and y that will work for both of the equations, at least for the linear ones here. So if we're asked to verify whether the ordered pair is a solution, we're going to take our coordinate 3 over 2, negative 1 over 2. And keep in mind, this is your x value, this is your y value here. And we're just going to simply plug it into both the equations and see if they work. So for the first equation here, I'm going to plug in 3 over 2 for my x. I'm going to plug in negative 1/2 for my y. So 4 times 3 over 2, that is equal to 6 because we can divide out the 2 from the 4, and then 2 times 3 is 6. And subtracting by 2 times negative 1/2. It's a crude looking 2, but it's fine. So negative 2 times a negative 1/2, negative is positive, and that's equal to 1. So it's plus 1. That's equal to 7. Hey, it works for the first one, but we need to check for the second one to see if that one works. So for our second equation, I'm going to do the same thing. Plug in 3 over 2 for my x. Plug in negative 1/2 for my y. Again, I butchered the 2. So negative 2 times 3/2, the 2 cancel here. So we're left with negative 3. And for the second one here, 2 times negative 1/2 you're just left with -1, which is -1, -4, which is true for our second one, right? So this pair is a solution,
And that's good. Don't do B.
and that's good. Which like you can tell that like that means B can't be a solution because there's only like one solution for that set of equations.
Mhm.
So any questions on this page?
You give them plenty of time.
Yeah.
Nope, go ahead.
Oh, sorry.
Let them look at it a little longer.
Sorry.
You're fine. All right, now you can move on.
Substitution. Oh, these are the different methods here.
Let's see if you have any questions.
Any questions on this page?
Awesome.
Go down here. Oh, and it's asking that we do two variables by elimination. And we're looking at number 20. So this is, I'm going to do it on notes. Like nothing breaks down. Okay. So we got 8x minus 4y is equal to 0. And we have a 0.5. I'm going to write that as 1/2, right? Same number. Plus 3/10, which is 0.3, right? Y is equal to 2.2. That's 2 plus 1/5.
Mhm.
It's just 11/5, right? Right. All right, is 11/5. And we're asked to do method by elimination for this. So method by elimination states that what we need to do is that we need both the equations to share a similar term. So what I'm thinking is I want, where I'm using fraction set of decimals, it's just easier to write that way because I don't want to have to do 2.2 times 3 in my head. It's just easier to think of them as a fraction. But it's still the same number, so you're still going to get the same answer. Yeah, you can do it either way. This is just how I'm personally going to do it. Right. So what I'm going to do is that you, according to the golden rule of algebra, I do one side as I do onto the other. So I'm going to take a look at the second equation down here, and I'm going to multiply both sides by 16. So can write this as 16 times 1/2x plus 3/10y is equal to 16 times 11/5.
Better start calculating the numbers.
X, yeah. I'll write this as 16 times 3/10 is equal to y, times y, and 16 times 11/5, right? I'm just going to express the numerators as products.
Mhm.
So now, we go ahead and get rid of this middle part here because. So now our two equations will look like this, and notice that they both have 8x, right? So what I'm going to do is that I'm going to subtract these two equations and eliminate 8x, right? Now I'm going to move the answer up here. Okay. So 8x minus 8x is 0. -4 minus this number, I'm going to write it as yeah. Can you tell me what that number is?
So it's the 16 times 3/10 is 4.8. -4, so it'll be -8.8.
Yep. 8.8 I'll write it as a decimal. Maybe I should have wrote it as a decimal in the first place.
All good.
Times y is going to equal. So that's 2.1. No, 2.2 minus 16 times 11 over 5 should equal negative 33. And now what I'm going to do now is that I'm just going to simply solve for y. I'm going to divide out negative 8.8. So y will equal 3.75. So now that I know what my y value is for both of those equations, I can simply just like plug it into one of my equations. Doesn't matter which one. I'm going to use the first one because that is neater numbers. So we can say 8x minus 4 times 3.75 is equal to 0. So 8x, and I kind of skipped the steps there. So 8x minus 4 times 3.75 is 15. Let's go to 0. So 8x is equal to 15 by adding both sides by 15. So x is equal to 15 over 8. And if I were to write that as a decimal, it'd be 1.875. So our order pair would be 1875, 3.75. This is your x and this is your y. Okay. Spent a good deal of time on that one, so we're going to move on to the next one. Don't need to worry about this stuff. We'll talk. Yeah, again, this is more data analysis stuff here. Solutions of linear inequalities. Any questions on this page? Ooh, 2 at the same time. We got 4 and 7. Let's see, Addison managed to answer first, so I'll go with that one.
Actually, go with 7, since Angel hasn't asked any questions yet.
Okay, you know what, fair enough. All right, so going with number 7 here, we have an x minus 5 is great. Sorry, x minus 5 over 2 is less than 18 over 5. So when it comes to solving inequalities, it's a very similar process of just solving equalities, but with some special rules that we need to keep in mind. So I'm just going to go and do this one first real quick. So we have a fraction less than another fraction. So what I'm going to do is that I'm going to do cross multiply here. Or in other words, I'm going to multiply both sides by 5 here to get rid of the 5 here. And I'm going to multiply on both sides by, well, you know what, let me do this first. So 5 and 5 cancel out on the right side here, but on the left side, I have 5 times quantity x minus 5. So this is 5x minus 25 is over 2 is less than 18, right? And now what I'm going to do is I'm multiply 2 on both sides here. So now I have 5x minus 2y is less than 36. Right. And now similar process to equalities, I want to get x by itself. So what I'm going to do is I'm going to add 25 on both sides. So we get 5x is less than 61. Yeah, 61. And finally, we divide 5 on both sides. We get x is equal to 61 over 5. I'll write it. Right. And now for number 4, it's a very similar process. Like I would distribute the 5 with the 2x and the minus 3, and then do the same process we did for this one to get x by itself. Just keep in mind when you're dealing with inequalities is that if you are dividing or multiplying with a negative number, you have to flip the sign. So just as a quick little example, if we had -3, x is less than 5, and I wanted to get x by itself, that means x would have to be greater than -5/3. So that's when you would flip the sign when you're multiplying or dividing by a negative number. Okay, just wanted to emphasize that because that's really important to remember.
Oh, don't erase.
Oh,
There you go.
magic.
All right, you got plenty of time for the last few pages.
Last few. All right, any questions on this page?
Move on to the next one.
Double inequalities, these are fun. Any questions on these?
Um,
26.
Oh, that's a good one.
Yeah, do have to write them separately though.
Uh-huh.
So on the left side, we have 1/2 x minus 3 is less than 5x. And or we can have the case where 2/5x minus 5 is greater than 6x, right? So in other words, we're basically going to solve these inequalities separately. So I'm going to focus on the left side here first. We have 1/2 x minus 3 is less than 5x. So I'm going to go ahead and subtract 1/2 x on both sides here, right? So we have -3 is less than, and if we combine like terms, should have 11 over, yeah, no, that's actually 9/2. I think I know how to do fractions at this point. There you go. Yep. All right. That's equal to 9/2, right? And I'm going to go ahead and do a nice trick. Since we are multiplying x with 9/2, I can multiply both sides by 2/9, the reciprocal of 9/2, to get x by itself. So -3 divided by 9 is -1/3, right? So that's equal to -2/3 is less than x. Right. Why wouldn't you multiply the denominator first? Well, I technically did multiply the denominator because I'm multiplying by 1/9, right? I'm technically dividing by 9 on both sides, and I'm multiplying by 2 on both sides at the same time. Right? If you can sort of think about it that way, it might be a little easier to see what I did there. I mean, instead of subtracting 1/2. I mean, you can do it either way. I just chose to subtract by 1/2 first. You could multiply both sides by +2, and it would work that way. So you could have had x minus 6 is less than 10x, and you could have just worked with integers from there. So yes, you could have done it that way. I just did it a different way. Okay, now to focus on the right side here, I'm going to do it. You said maybe I should have done the last one. I want to get rid of this denominator right here, this 5 here. So I'm going to multiply both sides by 5. Right. So 2/5 times 5 is 2 times x. 5 times -5 is -25. And this is going to be greater than 6 times 5 times x is 30x. Okay. So I want to get x by itself. So what I'm going to do is that I'm just going to simply subtract 2x on both sides here. So we get negative 25 is greater than 28x. And now if I want to get x by itself, I'm going to divide out 28 on both sides. So now we have negative 25 over 28 is greater than x. Yeah, I don't believe I can simplify that fraction any further.
Yeah, it's
Nope.
good enough.
Nope, that can't simplify it any further. I think it wants me to express this as a double inequality, so x is greater than a negative number, but it's also less than another number. So that means we can express it like this. I'm a little bit worried about how I wrote that inequality there, but your answer should look something like that.
Mhm.
So I'm going to move on to the next page. And these look to be
Word problems.
word problems, but we got 10 minutes.
Yeah. All right, everybody, we've got a little bit of extra time left over, and so I'd like to open it up to questions you might have from anywhere in the packet. So if you have questions you'd like us to go back and see, tell us the page number and the question number, and we'll go back that and work that with the time remaining. While you guys are looking through the packet, I wanted to let you know that this is being recorded. As soon as the video is done processing and I can get it uploaded to YouTube, everyone that attended this particular session will get an email link, hopefully late tonight. We'll just see how long it takes to process. In that email, you'll also get a link to a form to evaluate our session. Since we are fairly new in the process of having these online and in-person review sessions, any feedback you can offer us to help us make better sessions is deeply appreciated. I don't think they can hear me.
You are unmuted.
Okay, interesting.
All
All right, so,
you
you can, okay,
Fantastic.
fantastic, sorry.
Technology.
I've only got like three devices logged in right now. Thank you, Joshua.
So,
So, look for that form. Now I'm echoing. There we go. So look for that form and look for the link to the video, and we'll get that sent out to you this evening. So let us know, do you have any questions you'd like to see worked? You can drop those in the chat. Okay, if there are no further questions, feel free to head on out. If you want to stick around and ask questions, feel free to drop those in the chat. We'll be here till 7 o'clock. Oh, lots of thank yous. Cool. We're down to 2 participants. Awesome. if you want to mute yourself, feel free. He may not be actively participating.